Hello and welcome to a video on the t-test for dependent means, where we will go through another example. This time, so if you remember and you've looked at the previous videos, we've discussed the basic concept and the idea with some examples. Then we moved on to doing an example by hand, which is a very good exercise to do in the beginning, where you have your hand calculator to do the calculations. We're essentially going to do the same thing, but demonstrate how spreadsheet software like Excel can be used to make the calculator work more convenient. So we're not really using the full functionality of Excel for statistical functions that are built in and data analysis. We're sort of using it as a glorified calculator for the most part, but it has the benefit of laying out the information much more clearly than you perhaps would have had to write things down systematically from your calculator. So we're going to solidify the concept with another example, and our example is from this book that I really like. Not necessarily your prescribed textbook, but this is the one we're going to use for this example, and it's on page 268, and we're going to look at number 19 and read it together first. The amount of oxygen consumption was measured in 6 individuals over 2 10-minute periods. While sitting with their eyes closed, during one period, they listened to an exciting adventure story. During the other, they heard restful music. So, based on the results here, is the oxygen consumption less when listening to the music? So it is the same participant that is being scored or measured in 2 different situations. So we have a situation where the means of each test or score or measure, they are dependent on each other. So we are going to use a t-test for dependent means. And we're going to go through the hypothesis testing steps as we have seen before. Like I said, we're not explaining it again because we've had our discussion and an example by hand by the time we get to this video. So please watch those first if you haven't already. The beauty of a spreadsheet application is that I can lay out my calculations and my information in a much more convenient way. So I have the participations here, 6 of them, and I have the story, which we'll view as the before scores, and the music situation, the oxygen consumption levels. Those are our after scores for the same people. So then we're going to calculate our different scores as we start with an equal because it's a calculation, as after minus before. Instead of doing it by hand, we can use this as a calculator. And then the beauty is, you see here that it took this cell's information and subtracted the pink cell's information. I can now take this and the bottom right there where the cursor changes, drag it down, and then the formula gets copied. I can test it over here, and the reference cells move according to where my answer goes, exactly what I want. So this way I can very quickly calculate the different scores for all of these. Then we want to calculate the mean. Let's put the mean here. I'm going to make it green. Green is sort of formula cells, or where I calculate something. Yellow is where I have given information, like input cells. We're going to calculate the mean as simply the average of the difference scores. So we have a built-in function for that, average. I see it over there. As soon as I type a few letters, double click on that, and I'm going to select all these and then close my bracket like so. And then enter. So we have a mean difference score of negative 0.3. Now we want to get the distributions of the means of these different scores, and that has this mean as for our comparison distribution, but we still have to calculate the standard deviation of the distribution of the means. So we have our sample size of 6 here, and to get the variance estimate of this, we need to get the deviation scores and the square deviation from the mean. So for the deviation, that's simply going to be calculated as the score. In this case, we're calculating difference scores minus the mean, the deviation from the mean. Now I'm going to press F4 and make sure the mean is fixed so that when I drag it down, I don't want that pink cell to move with me because that's always going to be the mean value. So I drag it down in the same way and I test a random one and I see, okay, it took the right difference score and the mean that it's taking for the second number does stay fixed. So we have our deviation scores here. Then we want to square that. So I'm going to start my calculation. I want to square the deviation. So I take that and shift 6 is to the power of 2. That'll square it. And then I'm going to drag that formula or calculation down, test a random one, and I see, yes, it's taking the deviation score and it is indeed squaring it. So very convenient to use this, even just as a glorified calculator. So now I need to calculate the estimate of the variance of these difference scores as the sum or the sum of the square deviations divided by n minus 1. So we're going to go start here and we're going to go to our sum function and we're going to select everything we want to add up, and then we have to close the bracket like so, and then I'm going to divide by our n minus 1. But of course I have to put that in brackets. Now I can put in just a 5, I admit, but to be clear, I'll use the n and I'll subtract 1 like so, just to be a little bit more proper. You could have put that in as a 5 from the start. So there is the estimate of the variance, the unbiased estimation for our population of difference scores. But we are, of course, looking for a comparison distribution, that is the distribution of means of this. So let's reference the formula here. Let's go to the very top. Where do I go to the top here? I want to go to formula sheet. Let's go to the very start, just so I can show what I'm thinking of. Here we have the variance of a distribution of means is the variance of the population of individuals, in this case, individual difference scores, divided by the number of individuals in each sample. So I have to take my, now this is for the population, but the exact same thing is here for the estimate. So I have to take my variance estimation of the population and then divide it by the sample size to get the variance estimation for the distribution of means. So that's simple enough to do. We're going to take our variance estimate and we're going to divide by the sample size. So see how I'm much more efficient in my calculations because I don't need to type in numbers. I just reference cells where those numbers are already placed. And we get an answer like that. I don't even have to worry about accuracy. I don't have to worry about writing it down again. It's much more convenient. But I'm really doing the same things I could have done with my hand calculator. Now, we're of course trying to estimate the variance because our t score is calculated like so, essentially. The mean of our population, or our comparison distribution estimate, minus the mean under the null hypothesis, which we'll mention soon, divided by the standard deviation estimate of the comparison distribution, the distribution of means. So we need the standard deviation, not the variance. So we need to take the square root of that variance. And there is a function sqrt. Now let's suppose I had no idea, right? I didn't know what that looked like. I can always click here up where there's a little f function. And I can search a whole bunch of functions. I want to search for, now I can't make this bigger, unfortunately, if it's small on your screen. I want to search for the square root because that's what I want to do. But I don't know, perhaps, what that function is called. It'll give me a couple of relevant options, and I can click on the one I think, and then there's a description that says returns the square root of a number. Yeah, that's exactly what I want. I can click on OK, and then it asks me, just like in the brackets there, I could have typed it in, or it asks me here, what square root, the number of what? Oh, sorry, the square root of what do you want to calculate? I want to calculate the square root of this number. And I press OK, and you see here I could have typed that in as well if I know what the function name is. And you'll see familiar functions coming up over and over and over. So you do get used to it pretty quickly. So now we have everything we need to calculate our t-score. Just remember that we, based on the question, let's go to the question again, 268, number 19 here. We were interested in testing with a 0.01 significance level. Is the oxygen consumption less when listening to music? So from story to music, do I have a lower oxygen consumption? So I'm testing if the mean has decreased. So the mean deviation, I kind of want to be confirmed as negative. So I will just update this briefly. So the null hypothesis is that there is no difference and the mean difference score is 0 for my population, and the research or alternative hypothesis is that it is less than. That's specifically what I'm testing. So this is going to be a one-tailed t-test. So we need to keep that in mind when we determine the cutoff. So let's determine the cutoff next. And maybe a picture might be useful here. So let's draw a little picture. Now, I'm just going to draw on the screen because I don't want to bother with Excel to be too fancy here. Let's just do something like this. Did I click it? Sure. So if I'm looking at my t distribution, let's draw a little wobbly here. It's sort of like a bell curve, but the tails are a little fatter, but I can picture the same thing. We're looking for the left cutoff so that this over here is my alpha of, in this case, 0.01 t distribution. Now, I didn't say here the degrees of freedom. Maybe I should do that real quick. I can just insert a line here. Maybe I want the degrees of freedom for my t-test, right? Right-click, insert a new row. Maybe I want that to be degrees of freedom. And I'll make it green because I'm calculating something, but it's very simple. It is simply n minus 1. Now, I didn't need to do that because it's such an easy number. I could have put it in manually when I reference the t-score or think about which t-distribution I'm looking at. But it's nice to have it all laid out there. That's the benefit of having a spreadsheet. So I want to calculate this. Let's make this green as well because I'm definitely calculating something. I have the option, like before in our previous example, of looking it up in a table. But the table takes a little jumps to just be more convenient in a book. All of that information is actually in Excel already. So if I click on my formula or insert function tool, I'm going to move this so it doesn't overlap what I've written down. I want to search for t distribution. Now there's a whole bunch of probability distributions that it has information on. I'm going to scroll all the way down almost to t distribution. Now I know it's a little small. I can make this bigger. I have t distribution. I have a two-tailed, right-tailed. Then I have the so let's look at what t distribution says. It's taking an x, the degrees of freedom. It's a cumulative distribution. Then it returns the probability, the cumulative probability. That's not what we want. We have the probability of 1% or 0.01. We want to return this t value. So we want to look for the inverse. And we see there, it is returning the left-tailed inverse. In another situation, I could have a two-tailed test, then I would maybe use that. So just be aware there are different ones. So I'm going to go with that. My probability is this left probability, which is exactly alpha. So instead of typing in 0.01, I'll reference where alpha is placed. The degrees of freedom, I have that as well. That's over here, 5. And we can see that our cutoff t-score is negative 3.36. Let's write that in. Cutoff t cutoff negative 3. Oopsie. Erase. Negative 3.36. All right. That's our cutoff value that we're comparing against. Now I need to calculate my observed t-score. So let's start our calculation. Now I'm going to have to, I'll emphasize that at the top, whoopsie, I can never press. I wanted to press the back arrow to go into my brackets. It doesn't like that. I'm taking the observed difference, mean difference, and I'm subtracting the population mean under the null hypothesis, which is 0. I know I don't have to put that in, but I wanted to just for illustrative purposes. And then I'm dividing by my estimate of the standard deviation of the comparison distribution, which is this guy. See what we get? We get a negative, I guess that was green too, yes. Negative 2.4. So let's just visualize where that sits. Since these questions usually tell me, let's make it red. It's important. These questions usually tell me to draw a rough picture anyway. So I see, unfortunately, now I'm just going to give myself some space here. We have a t cutoff of negative 2.44 if I round, not cutoff, t observed of negative 2.44-ish. So we can now make our conclusion in our hypothesis test and say something like, let's say here, since our t, we can say t observed or t cutoff is unfortunately greater than t cutoff, or t observed is greater than our t cutoff. We wanted it to be more extreme. Then it would suggest that, okay, yeah, this red guy does not belong to this distribution. It's so unlikely to get things this far out. That would be strong enough evidence, but we didn't get that, unfortunately. So we can say the evidence is not strong enough to suggest that, let's say here, the null hypothesis is not true. I mean, we can't say it is true, but there's no evidence to really suspect that it is false. So we will not reject the null hypothesis. We're not saying it's true. The sample we had just led us to evidence that doesn't suggest that the mean difference is actually significantly less. So there we go. There is our another example using spreadsheets for calculations of a t-test with dependent means.